Hi there guys, Shannon Dowsing here. I'm here to make a quick little video to explain how the Wastewater Management Committee got to the preferred option which we presented to Council. So we have gone through a long process, but particularly in the last 6 months we've been in a wastewater options review group, which is a group of 4 iwi representatives and 4 council representatives, and we've gone through the technical details of how we can achieve the requirements set out by our consent. That resource consent has essentially 2 different streams that we need to consider. Now this is an obvious oversimplification, but it'll help us run through quickly how we got to where we are now. So if we first of all take the water quality requirements. So the water quality requirements are a interesting thing. Sorry, I'm writing on the other side of this blackboard, so glass screen, so all my writing's backwards. So water quality, first of all, we required biotransformation. That's what we're achieving right now through the BTF or trickling filter that we have. The next stage is to get rid of the suspended solids. The suspended solids are particles within the water which are a dense material, essentially all of the sludge that's still in there that is floating around in the water. So we need to remove these suspended solids. Finally, we have the pathogens and viruses, which are the determining factor for human health. We need to remove those to ensure that human health is maintained. Now, those are the 3 key elements within our consent. We then have, that's key in terms of water quality. We then have a set of cultural requirements. Now, those cultural requirements are based on our modern thinking around water, as well as the historic thinking around the life-bringing properties of water. So it's determined that it's inadequate to treat water as a disposable asset, and that it should be returned to a state where it provides life back to the earth. So there is a 2-step consent requirement, which is basically, first of all, it's progressive removal of wastewater from the outfall into the ocean. So we need to progressively remove quantities of water so that eventually we get to our target aim of total disconnection. So these 2 things essentially mean that we need to find a better use for the water, and this is the largest concern of iwi and also many other groups who want us to stop using the pipe in its entirety to take the water away from our treatment plant. They want us to find a better way to use it. So what's our current status? So if we look at what we have now, so we have currently a treatment plant, and in this treatment plant we basically have what's like a big tumble dryer. It's a drum which separates all of the hard materials from the wastewater stream. So there's bricks and mortar basically go down this pipeline all the time, lots of hard fill, and we need to separate that before it goes into our treatment. So that gets separated, water comes in, hard material gets separated and taken off to a landfill, and then the water that comes out is taken to our BTF. Now, the BTF itself is an interesting thing. It's basically a big tank full of what we call media, but it's basically channels for the water to run through, and an area for bugs to live on. So it's slugs and snails and lots of little creatures that are designed to digest our human waste and to turn it into a biological waste, non-human waste, I should say. So this is doing an excellent job of this step at the moment. In fact, it's doing a better job than we thought a single BTF could do. We did originally have 2 in the design, and now that we've seen the results of this one, we understand that in terms of that conversion, in terms of nitrifying or converting the bad stuff to good stuff, this is doing enough of that particular step. So from here, we then go currently to our outfall pipe, out to the ocean, and that's where the treatment cycle ends. The ocean does a great job of killing these pathogens and viruses, but not enough to remove the suspended solids and to allow us to treat those viruses before we just dispose of it. So what we need to do next then, because we have basically we've got a big tick for the biotransformation, now we have the suspended solids to deal with. So let's have a look at what we need to do next. So in these next steps, first of all, we'll look at the suspended solids. Now, we've looked at various different land-based treatments for this, and the smallest, most compact, and most efficient we've found is called a lamellar clarifier. Now, in terms of an engineering design, it's really simple. A big tank. In that tank, there's a siphon that captures all of the sludge, and that gets taken off to get composted. So our water comes in the top and flows in. It's forced to go up again through all of these diagonal plates, and the clean water runs off the top. So as the water tries to take that path down and around and up through these plates, all the heavy sediment drops out of the water, collects at the bottom here in the sludge settling, and then we can tap out that sludge. So that meets that second requirement. Now, the third water requirement is actually the easiest step, which is the pathogens and viruses, and that's just a UV treatment cycle. These are fairly common now and are dropping in price all the time. So just imagine some big light bulbs that use UV light to kill all the bacteria living within that water. So that gets us to our water quality standards. So what do we need to do after that if we want to reach our cultural requirements? So to create a situation where we can have progressive removal of water from the waste stream, we need to be able to give access to users. At the moment, this type of system doesn't allow us to access the volume of water that's required for our users. So we need a stage where we store the water, and if we're going to store that water, how do we deal with it? So we have another treatment cycle, which is a wetland. Now, the type of wetland proposed is a dense reed bed. So it is lots of grasses that are very tight together so that we don't get large birds nesting in them. We don't get geese and ducks and that kind of thing living in them, because that would create a airborne risk for things like the airport and that kind of thing. So the design of the wetland type has been considered, and lots of risks and associated information being gathered. This is about 12 hectares of wetland, and basically our water will flow from our UV treatment into the wetland, where the wetland does a great job of collecting those nutrients and taking that through the grasses. It also takes out lots of heavy metals, and it polishes that water so that industrial users or irrigation systems can use that water. So by building the wetland, we then give access, like a tap, that's available for people to use. So that gets us to the stage of our progressive removal. So for the interim, we will be taking that water, whilst we're looking for users, back to our outflow and back out to the ocean. And as new users come online, we'll be able to reduce how much water is going through this pipe at any given time. Eventually, with the aim of total disconnection, which is where we have enough users to take the full amount of water that we use. Now, there are a few considerations that we've made for how we could dispose of the water. The only realistic ones at the moment are disposal into the sand dunes. So we could put it into the dunes, which seems like a elaborate and expensive way to irrigate something that doesn't need irrigation. We have another option, which is the irrigation. So if we can find suitable sites for irrigation, for example, no one's going to want us to put treated wastewater onto their lettuces, but if you've got trees, for example, you can irrigate trees happily, maintaining that it doesn't affect the fruit. Then or golf courses and that kind of thing are perfect examples of sites that could be irrigated. Industrial users, there's a lot of users that have big water demands that can accept this site. We haven't identified any Gisborne users at the moment, but there are benefits to attracting those businesses to town. So industrial, and then finally there's been some discussion around an aquifer recharge scenario. And this isn't quite like the Macquarie aquifer, where we would be directly replenishing the aquifer to increase and sustain its level. This would be to do what's common in Australia in terms of creating a barrier to stop salt water penetrating into our aquifer. So because of the position, very close to the ocean, and then the dunes, and then our land, you can imagine that salt water gets down and into the aquifer quite freely. Likewise, our aquifer is always fighting against it, and as the pressure in the aquifer decreases, more seawater can get into that storage site. So if we can put in a pipe down and create essentially a water dam, it stops the water from the sea ingressing, and it stops the drain of our aquifer from upstream, so that this accumulates upstream and we no longer have that ingress. So it's something that's been discussed, it's something that's done elsewhere in the world, but it's not something that we've had the scope to research within our committee. So all of these solutions are something that going forward into the future, councillors and new councils will need to be considering alongside our partners in iwi and in business. So this part becomes partially an economic development project, partially a cultural development project, but essentially an opportunity for council. So that's how we got to our preferred option. So to tell you what's next, we've got the requirement essentially to do at least this much, which is the water quality portion. Now that we know needs to be done to meet these steps, and this will get us to a position where we are confident that we're equivalent or similar to other regions in New Zealand. Of the 50 odd locations in New Zealand that pump their wastewater to the ocean, we have the third worst treatment. The only two below us are still on the screening processes, so no treatment of their wastewater, and everybody else is better than us. So we know that we've got to make a step, we've got to make an improvement, and this is the water quality improvement. What we came to as the wastewater and committee was that we needed this extra step here to meet all of our consent. So really, that for us is our ideal. This is our must do. This is our must consider. And this, hopefully one day, is our must go. But that's where we are currently with wastewater. Thanks very much.